In the vast, cold reaches of deep space, every now and then, something happens that reminds us just how little we truly understand about the universe we inhabit. Among the most astonishing of these reminders are the sudden, brilliant explosions now known as luminous fast blue optical transients, or LFBOTs, events so energetic, fleeting, and bizarre that they have captured the attention of astronomers around the globe. And while they remain a mystery for now, they may hold the key to solving some of the biggest puzzles in astrophysics, including the elusive existence of intermediate mass black holes and possibly even a deeper understanding of dark matter. It all started with a cosmic event affectionately nicknamed the Cow. Spotted in 2018, this explosion stunned scientists with its brightness, speed, and strange flat shape. It wasn't just another supernova. It was a supernova on steroids, erupting with a force 100 times stronger than typical star deaths, yet fading in just days, rather than the weeks or months seen in usual supernovae. It looked, in short, like something entirely new. And since that moment, it has become clear that it was not alone. Other mysterious outbursts have followed: the koala, the camel, the finch, and most recently, the wasp. Each has been tagged with quirky names and designations based on their discovery labels, but they share several fundamental traits: blinding brightness, a fierce blue hue indicating extreme heat, and a lifespan too short for traditional explanations. These transients have now formed a tiny but growing family of cosmic oddities. And while they've puzzled astronomers, they've also inspired a wave of creative, hopeful inquiry. Because behind every unexplained flare in the sky is the promise of discovery. One of the most exciting theories is that LFBOTs might be the signature of intermediate mass black holes, a long-sought class of objects that could finally bridge the gap between the small black holes formed from dying stars and the monstrous supermassive black holes that sit at the centers of galaxies. These mid-sized black holes, if they exist, might be swallowing stars whole, tearing them apart with immense gravitational pull, causing sudden, brief, and brilliant explosions like those we've now observed. This idea isn't just speculative anymore. Detailed data from the Hubble Space Telescope and X-ray observations of the original Cow event suggest a flattened disk of debris, something consistent with a star being shredded by gravity and spiraling inward. As that stellar matter disappears into the black hole, it likely ignites bursts of energy, creating the brief, dazzling signatures we're picking up on Earth. That would make each LFBOT not just a mystery, but a cosmic crime scene, evidence left behind after the violent destruction of a star. If this interpretation proves correct, it would be groundbreaking. It would mean we've finally found intermediate black holes in the wild, offering an entirely new class of celestial object to study. These are the missing links in our understanding of black hole evolution: how they grow, where they form, and how the largest ones came to dominate the centers of galaxies. It's possible these mid-sized objects played a central role in shaping the structure of the early universe. There's another, perhaps even more astonishing possibility. If intermediate black holes turn out to be more common than we thought, and if they can only be detected during violent events like LFBOTs, then these sudden flares could help map a hidden population of black holes throughout space. That opens the door to a deeper understanding of dark matter, the mysterious substance that makes up most of the universe's mass but does not emit light. Could intermediate black holes account for a fraction of that hidden mass? It's too soon to say, but the question is now on the table, and that alone is thrilling. Even competing theories are rich with promise. Some researchers believe that LFBOTs might involve massive Wolf-Rayet stars, incredibly hot, powerful stars in their final stages of life, being devoured by smaller black holes. Others propose failed supernovae, where stars collapse inward instead of exploding outward. But none of these ideas fully explain the speed, brightness, or shape of these flares. And that's the beauty of the mystery. It's forcing scientists to reevaluate what they thought they knew about how stars die, how black holes form, and how energy travels through the cosmos. There is, of course, a warning hidden in this wonder. As powerful as our telescopes have become, we're still often caught off guard by these events. LFBOTs rise and fall in the blink of an astronomical eye, and if we're not looking in the right place at the right time, they vanish without a trace. The rarity of detection limits our ability to gather enough data to draw confident conclusions. Right now, we've only seen about a dozen of these events. What we really need is hundreds, but the future looks bright. The upcoming launch of the Ultrasat telescope, an Israeli space observatory with a wide field of view, could soon change the game entirely. With its ability to sweep across vast portions of the sky, it's expected to catch many more LFBOTs and other transients. This could rapidly build the catalog of events scientists need to crack the code. And as always, collaboration between Earth and space-based telescopes like Hubble and James Webb will be crucial in studying each explosion in detail. In many ways, the story of LFBOTs is a testament to the power of curiosity and to the value of keeping our eyes on the skies. These strange explosions weren't predicted by theory. They weren't anticipated by our models. They simply happened and we noticed. And from that noticing, a new chapter in our understanding of the universe is being written. Slowly, flare by flare, we're peeling back the layers of a cosmic secret. It's a thrilling reminder that while we may live on a small planet orbiting an average star, we are part of something much larger and more mysterious. And that mystery is not something to be feared, it's something to be explored.